This session will demonstrate how generic or standard spectral functions can be used to produce non-stationary random vibrations. Generally, many labs use generic PSDs such as those published in various standards. For example, we can use the truck steel spring suspension PSD published by ISTA, or the truck leaf spring PSD from ASTM. When using ordinary random vibration controllers, the only other variable that can be configured is the RMS level that remains constant throughout the test. This approach is very limited and does not produce realistic vibrations. With the statistical vibration synthesizer, some reasoning can be applied to produce non-stationary random vibrations by defining a range of RMS vibration levels to be simulated. This is done by creating an RMS or vibration dose table. Once the pointer is located on the RMS distribution graph, the right mouse key is used and the Edit RMS Library option is selected. This opens Microsoft Excel, which already contains a number of predefined RMS distribution functions. Here I will show you an RMS distribution that I have already created and is based on a proportion of 50, 30 and 20%. These represent the proportion of the overall test duration that each of the corresponding RMS levels will be synthesized. The main difference here is that the fluctuations or variations in RMS levels will be random. If we start by entering 0 in all the cells, we can select that for 50% of the time the RMS level will be, say, 6.5 meters per second squared. For 30% of the time it will be 8.5 meters per second squared. And finally, for 20% of the time, the RMS level will be 13.5 meters per second squared. These are arbitrary values which I have just made up. In practice, they will be based on test specifications. This new RMS distribution can be saved, and because we have edited an existing worksheet, all that needs to be done is to reselect the worksheet from the available list. And here is the new RMS distribution. This is a very simple way of taking full advantage of a statistical vibration synthesizer system. Once the system is activated, the random vibrations will be synthesized for each of the RMS levels, but in no particular order or sequence. At any one time, the RMS level could be any of the three preset values, namely 5.5, 8.5, or 13.5 meters per second squared in this case. What is important is that at the end of the test, these vibration doses will have been realized, and critically, that the PDF of the synthesized vibrations will conform with the target PDF, along with the kurtosis value. The website contains a video demonstrating such a test whereby a generic PSD was used in conjunction with an artificial RMS distribution to produce non-stationary random vibrations.